Hello, this is Lewis from the future. By the end of this video, we'll have something that looks like this. This video is about introducing you to the vertex attributes and uniform variables, and a bit of an introduction to what we'll be doing in the next video. We'll basically be going over some concepts and things we're going to need for our particle system. So this is going to be 2 or 3 videos in a row to make a particle system. I did record a very long kind of draft video to put this particle system together, and I'll upload that after I've done the edited videos, because these edited videos will be much better learning material. The long unedited version is just extra, and if you want to follow that as well, then if everything's not making sense, then you can see the whole process that I go through. So this first video, we're going to explore what's happening in the mesh class and what we're using to make the particles. We're using the template that I put together from my GitHub. The link's in the description. And if you followed the first video, you should be able to set up as quickly as I do here. If not, in the first video, I go through how to set up, or you can use the README. You don't actually need to watch the whole video. It's just the first 8 minutes, and that gets you to the setup and ready. So currently we're telling the mesh class to create a triangle and then draw it. This is known as high level because we don't see the nitty-gritty details. But for the mesh to create a triangle, it has to do some low level stuff. And before we get to that low level stuff, let's just make a square. So a quick video before we make the square we need to set up, because there's a couple of things we need to change. So the first thing is we need to get rid of this mesh equals mesh, and then create the mesh thing. So that we get rid of that. And then down here we've got the same thing in the else statement. So what we've got here is an if statement to choose whether we're using 2D or 3D. At the start, that's either true or false right at the top here. If we change this to true, then we'll all be working in 2D, but I think, yeah, we'll keep it as false for now because it will be more interesting to work in 3D. So what you can do is minimize this first bit here, if's 2 dimensions, and we're going to be doing all this. Now, very quickly, we want the mesh to equal mesh to make the construction thing, mesh.create triangle, and then in the while loop here, we've got mesh.render mesh, and that should all be back to working order. Just double checking. There we go. We've got a triangle. Okay, back to the unedited, well, the actual edited bit. We're going to need to lay out this information for a square in the format that the mesh class is expecting it. This won't make sense yet, but it will do. So the vertices. We're creating an array of floats. This is a static array, meaning we can't change the size without doing some real magic stuff. I'd usually use a vector class, which means we can use a dynamic array, and it's a bit easier to use, but using a static array like this means I can lay out the data so you can see how we're using it. We have the XYZ coordinates for the top and bottom left and right vertices. These 2 values on the end are the UV coordinates for the textures, but we are not using these, so we can ignore them for now. If you're unfamiliar with these terms, we're going to be using these values to play about in the shader, so don't worry if it's not making sense yet. It will. And now the indices. We're not going to use indices for the particles, but because of the way the mesh class is made, we need the indices for OpenGL to know the order the vertices need to be drawn. I'll do a quick video on that now. So these indices, we got the basically I've drawn out the vertices like we've got them there. So you got, and then indices, it says 0, 1, 2, 1, 3, 2. So what's that actually doing? We need to tell OpenGL, with this function specifically, we need to tell OpenGL the order in which to draw these indices, these vertices, sorry. So we use an index-based draw, which is basically listing how to draw the vertices. So we have 0 here, and then we go to 1, then we go to 2, and that makes the first triangle. And then the second one is 1, 3, 2, and 1 is there, 3, 2, and it makes the second triangle, and that's how we're making our square. That's index-based drawing. I think that's the concept. Anyway, that's how it works. With these 2 arrays, we just need to pass the information to the mesh class and then render it. Now we have a square. So this low-level stuff I mentioned earlier, let's open up the create mesh function by right-clicking and going into the declaration/definition. This is expected of you as a beginner. It's, in my opinion, insane for you to understand any of this by simply copying what's on a tutorial and making a triangle out of it, which is how I learned, by the way. We're not going to touch on this bit yet. That'll be for the next video, but underneath these bits is the vertex attribute pointers. This overly complicated looking thing is actually our friend. Let me open up the vertex shader in the template folder of the project, and at the top here we have the layout location equals 0 in vector 3 a pos. Let me just rename this so it makes more sense. It's the position data for the vertex. One thing missing here is actually location 1, the UV data that we're not using. These two are vertex attributes. They allow us to add customizable data per vertex. These basically tell OpenGL where this customizable data belongs. If we Google this function, we get some complicated information, but it doesn't take long to understand. Index. This specifies the location of this data in the shader, which is the location 0 or 1, like I showed earlier. Size, how many values? For us, that's 3 for X, Y, and Z positions for the data, and then 2 for the UV coordinates for the texture, which we're not using. And then type, all of these are type GL floats because they're float type parameters basically. What's next? Normalized. This is a maths term. The most generic way to explain this is that normalizing this data turns a position into a direction, and we don't want that, so we're going to set this to false. Stride and pointer are a little bit complicated. Stride is the length of the data per vertex. Ours is the XYZ and UV values, so the stride is 5. But it has to be the size of the data in bytes, so that's 5 times the size of a float, which is 4 bytes. So that makes our stride 20 bytes. Then the pointer for XYZ is 0 because it's at the start, but the UV coordinates, the pointer is basically having to skip over the first 3 values to get to the UV values at the end of that line. I think that might be enough of that complicated stuff. We're going to be writing it in the next video anyway. Let's just do some code. So hopefully you followed along and you have some floats here for vertices, gluints or OpenGL's version of unsigned integers for those of you wondering what they are. A couple of things here. Make sure you have an equal sign here or you won't assign anything to these arrays, and make sure you don't forget this semicolon on the end either. Now, when I was going through the mesh class, I realized we have a setup for if we want 3 values on the end, which is perfect for the red, green, and blue values. So let's add some more experience with vertex attributes before we move on to the next video. Let's go to the mesh creation function and use this. Highlight this lot and click this button at the top to comment out this code so we're not using it. Now remove these bits here so we can use these. This is exactly the same as below, but with 6 pieces of data per vertex, with 3 values for the XYZ and 3 values on the end, UV and W for why not, but it's not really. So now we've done that, let's go back to our vertices and add these, this extra W value on the end, and instead of referring to these as UVW, we'll call them RGB. Assign whatever combination of color you want to these vertices, or just copy what I'm doing, it doesn't really matter. Right, hello again. So the rest of this is going to be improvised so that you can see the kind of problems we're going to run into and how to fix them, rather than me just showing you exactly how it's done. So hopefully I'm at the same point you are. We've got the XYZ coordinates there, we've got the RGB coordinates, I suppose they are at the moment. They're not really, they're just the RGB values. Put some random ones in there. We've got the create mesh thing with the 24 values there because there's 24 values in this array. Down here we've just got a set uniform object color. If I run this at the moment, it should be a red square. Cool. So from here, let's play with stuff in the shader. So right click here, open File Explorer, go to the template folder, go to shaders, and then we're going to open up the Vert shader and the Fragment shader. You can literally just open up with Notepad, right click, open with, and open with Notepad. Right. So we've only got the position data in there at the moment. So we're just going to say layout location equals 1 in vec3 color data, and that's our colors here. And we need to use this data, but we can't use it in the Vertex shader. We need to use it in the Fragment shader because the Fragment shader assigns the color. So we want an out parameter, vec3, and we're just going to call that color. And then here we just need to assign that color. So color equals color data. We could always animate from here, but I think it's best to continue with what we're doing. So we've got an out parameter here, which is basically the Vert shader sending this value out down the pipeline. We just need to identify it on the way back in. So the Fragment shader is going to try and look for a value of vec3 type called color, and then simply all we need to do here is define a vec4 because there's going to be 4 channels, the RGB and alpha. So color, and then the last value, the alpha, needs to be 1. Now we should have a multicolored There we go. Now, some stuff that might happen, for example, if you were to, if I just comment this out quickly and just copy this, what I did originally in my video, and what you're likely to do by accident, is simply just assign the color like this, and you'll get just a white box come up, and at the top of this you'll have some information. So failed to compile the fragment shader, error, assignment of incompatible types. Make sure you make note of the line, because that makes it easier to identify where the error is, and that's the kind of things you're going to run into. It's just a case of experimenting until you understand, really. Okay, so we've got that assigned. Let's animate this. Oh, I've accidentally closed the shader. Let me just go back and open that up, sorry. Go back to the thing, go to template, shaders. We want the frag shader. I see the frag shader I closed. Yeah, it was. And we'll keep that open for now as well. And we need to assign now a uniform. So above the out vector, it doesn't really matter too much. We just want a uniform float called time. And if you, one thing I forgot to do was actually define the type, and I called it just uniform time. So I'll show you what happens when we do that. Anyway, in the while loop, we need to assign this value. So it's simply shader.set uniform. Keep up with me. There we go. Called time. Just going to assign this glfw get time. This is a function inside glfw. It's basically gets it just updates the time constantly every tick, and it's since the project was run. So I haven't done anything with it. Anyway, we've got a problem straight away, because it says failed to compile the vert shader, syntax error, unexpected : expecting that token this. So that usually actually identifies that the time isn't a value as well, but I haven't actually used it, so this will make it look a bit more like what we were expecting the error to look like, which is, let's just do color equals 1 minus sign time plus color x. Let's do this for the x there. Close that, and underneath here we'll do the same thing, but for the, oh gosh, I haven't put a dot there. There we go. Dot z, because the y value on my color is actually nothing. This would technically be the x for the red component and z for the blue component. Now if we run it, we're going to get the actual error message that I was expecting that time, which is error undefined variable time, and we've also got an undefined variable color, because I've put color in the wrong there we go. That's supposed to be a capital C, and it was a lowercase c, and time is actually undefined because it's not of type float. So now we should have some animated color going on there, which is fun. And lastly, one of the things I wanted to show before finishing was the difference between uniform and vertex data. So vertex data we can update per object, but uniform data can be only updated per, no sorry, vertex data can be updated per vertex, but uniform data can only be updated per draw. And that means when we render, we can't draw anything whilst it's well, we can't use any uniform, can't change any uniform data whilst it's drawing the rectangle. So let's quickly give an example of that. Let's make a uniform vec3 called position offset, and we're just gonna, oh actually let's animate the position as well. So just down here we're going to put a new thing called vec3 position equals position data. You might be wondering why we're creating a vector 3 here and not just updating the position data directly, and the reason for that is because we can't update the position data directly. It's a read-only thing. If you remember, we made it static draw, which basically means once that buffer is updated once, we can't update it again. So trying to update this data will cause an error. So instead we just declare a new vector 3 there called position, and we're going to animate this a bit. So we want, let's say position.x equals plus equals time oops sorry, sine time plus, oh, actually no, sine time plus color data dot x. And what that's going to do, because we've got my colors here, they go 0.25, 0.5, 0.75 up to 1. The every single vertex is going to have a different value there, and because it's a sine wave, all these different values are basically, you know, incremental. And through the wave, it's not like it's incremented by 1 and going through the whole thing. It's going to be kind of interesting, hopefully. And then finally, we want position plus equals position offset. And what this is going to do is add on the uniform that we assign in a minute. And then finally, we need to put position inside this last call at the bottom here, which is basically a few things there which I haven't explained, but this is the GL position, which is where the final part of the vertex is like kind of assigned. That's it. It's done with the vertex. After that, we could always change some things like the size of the points and whatever vertex attributes are set for OpenGL, but that's a bit more advanced. I won't go into any more detail with that because that's just silly. We can do that. We'll do some of that in the particle shader though. Right, so we just need to assign this position. So down here, if we say shader.set uniform 3f position offset, I think it was called, position offset, and then we just need to assign some values. Let's say 1.0 on the x, 1.0 on the y, and oh, I'll tell you what, let's make 2.0 there. Oh my god, sorry, can't type. 2.0 on the z, just to make it kind of interesting. Now that's the uniform data done. If we copy this entire thing, actually we don't need object color anymore, so I'm going to get rid of that. If we copy this whole lot underneath here, and we divide uniform time by 2, or actually times it by 2, because then we can really clearly see the difference. Let's times it by 3 just to be insane. We're going to put this as minus x, minus 1 on the x, minus 1 on the y, and then let's put this as 0 so it's a bit closer than this one. Let's see what this looks like. Well, we've got one triangle. I don't know where the other one's gone. If I put this minus 2, maybe it's inverted. It might be that minus is but actually forward. There we go. So we've got one in the background, one at the front. And because I want to see that one next to the other one, I'm just going to change that as well. There we go. We've got some fun stuff happening in the shader. Nothing amazing, obviously, but this is the kind of like the basics before we move on to making the particles. So in the next video, we'll be creating the particle class. We'll be creating our own version of the create triangle, but basically instead of a triangle, we're going to use some stuff to make a bunch of particles. It'll be anywhere from 1,000 to 1,000,000. It depends on your processing power, really, and what kind of graphics card you got, and we'll just see what happens, really. It'll be a lot easier than this video, which is kind of strange because this video was hoping to be kind of just like an introduction, but it ended up being quite complicated because we're trying to work with what we have rather than creating what we need. And creating what we need is actually much simpler because we just can do it from scratch, and there's no going back and redoing things like I'm doing right now because it's not working as well as I hoped. Anyway, I hope you enjoyed, and I'll see you next time.